All right, so we are graphing again today, but before I start that, we're starting chapter 8, which is about exponents and also about something called logarithms, which you have not worked with yet. So we're going to get to that eventually, and learning some new buttons on your calculators. But today we are graphing exponential functions, and all of our graphing rules still apply, like I have been saying all year long. So the plus and the minus that you see always means you're moving the graph left or right, up or down. And then we've got these two things right here. And so I'm going to start, I'm not going to show you what the parent graph looks like. I'm just going to start right in with looking at this example down here. So y equals 5, and then parentheses 3 to the x power. Now, up here it says this first number, whatever the a is, that's your initial value or your y-intercept. So at 5, 1, 2, 3, 4, 5, we're going to put a dot right there. Okay, this number tells you it's growth or decay. This 3 is a big number, so that means it's going to be a growth function. So here's what it looks like. It's going to go up like this. So it's a swooping motion here, and this right here is your asymptote. Now remember, an asymptote is a line that the graph gets closer and closer to but never crosses. So it will never go below that horizontal line right there. Okay, and that horizontal line moves with the graph if it tells us to shift it, and we'll see that on another example. Okay, so the first number tells you where it goes through on the y-axis, and then it's just it starts at a flat line and it kind of curves upwards to the right every time. Okay, questions on that? All right, so let's see another example. So we've got some clues right here, and when I graph, I always draw arrows to the things and say what it's doing to the graph. So the negative right there is going to flip it upside down over the asymptote. The 4, again, is your y-intercept before we move it. And then we've got some moving numbers. So what direction is this one going to take us? That one is going to move us right, because it's the opposite direction you think it should be. So -5 you would think would go left, but it actually goes right. And then the numbers on the end always move us up or down. So we are going up. All right, now there's a process that works best to go through these. So what I'm going to do is I'm going to graph this multiple times, and then the final one I'm just going to darken in and say that this is my final answer. It tends to work a lot easier than to just do it all at once, so take it in steps. So what I'm going to do right now is I'm just going to focus on what we did on the last example, where we put our dot on there and then we get our curve drawn. Okay, so I'm just looking at the 4 and the 3 right now. So this 4, and I'm not paying attention to the negative, we actually do that flip at the very end. This would be our y-intercept, so we're going to go 1, 2, 3, 4. We're going to put a dot, and then we get our curve on here. Okay, so it looks something like this. Okay, we've got our asymptote right here, right along the x-axis. Okay, so we just look at the 3 and the 4. So I'm going to write some steps over here. So just look at A and B. Okay, and what I mean by A and B are these two right here, A and B. Okay, so we graph that. Okay, after that, we're going to move it. Okay, so we're going to shift right and up on this one. So we're going to take this dot. I'm going to change my color so you can pick a different color with your iPad. And we're going to move this dot. This is what we're going to focus on. This dot is going to move right 5 and up 2. So we'll go 1, 2, 3, 4, 5, up 2. Our new dot is here. Now the asymptote moved with it. If we take this dotted line and we move it right 5, does it change? No. Does it move up? It's going to move up 2. Okay, so our new asymptote is here. And the graph now looks like this. I promise you, if you follow these 3 steps, you're going to get them right way more often than not. The last step, if at all, is to flip it. Okay, now we do flip this one because there's a negative at the beginning. So we just need a mirror image of this green arc right here. So this dot, 1, 2, 3, 4 units above your asymptote is going to go 1, 2, 3, 4 units below your green asymptote. And now you just need a mirror reflection of that green curve. So it's going to look like this. Okay, now you have a couple of options. You can either highlight this a little bit darker. That will tell me that that's your final answer, or you can simply just say, this is my answer, and I will ignore the other two graphs. Okay, I am definitely looking for this dot though, so keep it highlighted. Okay, that tells me that you know where to put that. Questions on that? Follow these 3 steps in order. Now we need to talk about the domain and the range, okay, because they asked us to do that. So if we're looking at just the red graph, domain, we're taking a scanner, pretend this is our scanner and we're going to travel this way. Okay, we're looking at the red arrow. What's our first thing we write down? It's pointing at negative infinity right here. So we got negative infinity. Okay, as we scan this way, where do we go? Positive infinity. Range. We start with our scanner down here this time and we travel upwards. So what's the first thing we write down? This arrow tells us that it's going to negative infinity. And does it go to positive infinity? No, what does it stop at? Stops at that 2, this green asymptote right here. This is where it stops. Now, why do we have a round parenthesis on 2? It's never going to touch 2. It's going to get it closer and closer and closer and closer to 2, but it will never touch it. Okay, so we're not including 2 in our answer for the range. Questions there? Okay, let's try one last one right here. Okay, so let's talk about this. We have, what does the negative do? Okay, so we're going to flip this one at the very end. What is the 1/2? This is the y-intercept before moving. Okay, what does this mean? Move where? Left. Where's this one moving? Down. Okay, now, this right here, we're going to talk about this in a second, but I want you to write decay right there for the 3/8. Let's answer this question first. How do we know that that's decay? What's telling us that it's a decay function versus a growth function like the last two were? Fractions. Yes, it has something to do with fraction, but more specific than that. It's less than 1. Okay, you could have a fraction in there like 3/2, but that would be a growth function because it's bigger than 1. Okay, so if you have a fraction that's less than 1, then you know it's going to be decay. So here's what that one looks like. Now remember, okay, so that's the answer to that. B is less than 1. We're still going to have the same 3 steps. So we're going to graph A and B first. So we're looking at the 1/2 and the 3/8. Okay, 1/2 is your y-intercept, so we put a dot right there. Now a decay function just means it's getting smaller, okay, or less. So instead of being growth where it grows up and to the right, decay slides downhill. Okay, our asymptote is still on the x-axis, but it's not growing, it's decaying. Okay, so we graphed A and B, that was our first one. Now we're going to move wherever it tells us to move it. So I'll pick a new color. So it says we need to move left and down. So we'll take this dot right here. We'll go left 1 and down 3. 1, 2, 3. There's our new one. The asymptote also moves. When we move it left, it doesn't go anywhere. It doesn't change, but it is going to move down 3 with our graph. So that's our new asymptote right there. And we've got our decay happening here. So that's step 2. And then lastly, and this isn't on everyone, but if you need to flip your graph, we'll flip it, which this one we do need to flip. Okay, so this is just a mirror image flipped over your dotted line or your asymptote. So this dot, we're going to reflect over the line. So it's the same distance away from the line, which is half of a unit here. And then we just create a mirror image. Okay, and then you either write answer by it or you darken it in so that I know that this is the one I should assess and attach a grade to. We also need to make sure that this dot is highlighted. Now let's talk about domain and range. Okay, so domain, we're scanning left to right. What are we going to write for domain? Is it going forever to the left? Is it going forever to the right? Okay, then that's negative infinity to infinity. Range, we start at the bottom and scan up. Do we have negative infinity? Yep, this arrow is pointing negative infinity, and then it goes all the way up to what? Negative 3. So negative infinity to negative 3. Questions? Good question. Good question. So this dot right here is at negative 3.5, but it's going to continue to creep up and up and up towards that 3. So that's going to be your cutoff point that it's getting closer to. Other questions?